Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello, Pak Haniif and friends. We are from Group 3 International Class with our members are first Muhammad Mahfud Muzadi with student number 19. The second is Devania Helena Kharisma with student number 43. The third is Lathifa Rahma Astuti with student number 46. And the last is Nevy Ainurrahmah with student number 49. So here we are going to explain about multiple effect evaporator calculation. This is actually, we are searching for the simple one. So the problem is a solution with a negligible boiling point rise is being evaporated in a triple effect evaporator using saturated steam at 121.1 degrees Celsius or 394.3 Kelvin. The pressure in the vapor of the last effect is 25.6 kilopascal absolute. The heat transfer coefficient for the first evaporator is 2,840. The heat transfer coefficient for this is 1,988. The heat transfer coefficient for the third evaporator is 1,420 watt per meter square Kelvin. And the areas are equal. So the question is estimate the boiling point in each of the evaporators. From the question above, we can make a conclusion for the known. The temperature of the steam is here, 121.1 degrees Celsius. And the pressure on the third evaporator is here. And this is the heat transfer coefficient for the first evaporator. This is the heat transfer coefficient for the second evaporator, and this is the heat transfer coefficient for the third evaporator. So because the areas are equal, so we can make a conclusion that A1 is equal to A2 is equal to A3, it is equal to A. So the next step will be explained by Nevy.
Okay, here we have to find the boiling point in each evaporator. First step, we need to find the T3 or boiling point in the third evaporator first, because from the question known that the P3 pressure on vapor in the last effect is equal to 25.6. We can find T3 by using the table line, and here we just input the data of 3 and then click calculate, and after that we get the result that P3 is equal to 65.4943 degrees Celsius. And after that we need to find the UOV or overall heat transfer coefficient. The formula to UOV is 1 per UOV is equal to 1 per U1 plus 1 per 2 plus 1 per U3. Because the value of U1 and U3 have not from the question, we just input the value and then calculate. And after that, we get the value of UOV, overall heat transfer coefficient, is equal to 641.2903 watt per meter square Kelvin. And for the next will be explained by Devania.
Okay, thank you. The next step, we must to calculate the heat balance in each evaporator. The formula is the overall heat transfer times by area times by temperature of steam and minus by temperature 3 that equal the U1 equal to U2 and equal to U3. So because we must find the temperature 2 using the formula that the overall heat transfer equal to heat transfer 3. And why we don't use the area? Because all the area are equal. So the next step, we input the value of the overall transfer, that is 641.2903 times by temperature steam, that is 121.1 minus by 65.4943 943 that equal to U3 times by temperature 2 minus temperature 3. So we put and input all the value on this formula. So we get the temperature true, that is 90.60655 degrees Celsius. Okay, the next step will be explained by Muzadi.
Okay, thank you. So next, to find the boiling point in the first evaporator, or T1, we use the heat balance equation described earlier, yeah. But we use the first equation and only the second equation, which contains the T1. So we use the equation of U overall times area times the steam temperature minus the third temperature equals with U1 times the area times the steam temperature minus the first evaporator temperature. So as I already mentioned in the problem that the area has the same value, so we just ignore it. So we get the equation of U overall times the steam temperature minus the third temperature equal to U1 times the steam temperature minus the first evaporator temperature. So next we input the value of each known component so that we get 641.2903 times 121.1 minus 65.4940 equal to 2,840 times 121.1 minus the first temperature of the first evaporator temperature. And then we do the calculation, then we find the value of the T1 is 308,264.6207 divided by 2,840. And then we get the first evaporator temperature, or T1, meets the value of 100.5439 degrees Celsius. And then for these problems, we get the boiling point of each evaporator. So for the first evaporator, or T1, we get the value of 108.5439 degrees Celsius, or it also equal to 381.6939 Kelvin. And for the second evaporator, or the T2, is equal to 90.6065 degrees Celsius, and also equal to 363.7565 Kelvin. And last, for the third evaporator boiling point, meets the value of 65.4940 degrees Celsius, and also it equal to 338.6440 Kelvin. Okay, that's all for me.
Okay, I think that's all from us. We are sorry if there is any mistakes. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.